everyone. Today we talk about the solvers, and there is two types of solvers in MATLAB for different according to our model. We will select solvers settings, and there is fixed step solver also and variable step solver. We will see how we can select for which model we should select which solver. Okay, and the first is a fixed step. You can here the step size is constant, that we can't change throughout the simulation. It is a fixed constant step size only. But in variable step size, this is a like it varying according to the model dynamics. How the model is according to that model dynamics, the step size will vary. Okay, and if we want to generate code for our model enough to, and we want to simulate with our real time computer like microprocessor controllers, then in that case also we will be using fixed step solver. We can't simulate variable step size with the real time. And here I am taking one example. Suppose we have two inputs. 0.1 input is running at the sample time of 1.5, and other input is having sample time of 0.75. So if we want to cover both execution rates, then we should be giving one common sample size so that covers both of inputs. So that calculation we should do while selecting the fixed step solver. uh, so here you can see 0.25. I am selecting the step size of 0.25, then it will covers the both 0.255, 0.75 is covering here one. Like that it will continually adding up the time sample time. Okay, but in variable step size it will vary according to our models. Whatever the input is coming, accordingly that input our step size also changes. So you can see here step size is first 0, then our input is giving 0.5. Okay, we taken that 0.5, then our output sample time input sample time changed to 0.75. Again we are taking 0.75 here, 1.5, and is, you can see here 1.5 taken 7 steps here to reach 1.5. But here 1.5 to reach only taken 5 steps. So simulation duration for the fixed step size is increases because we are taking one fixed step size here. But for a variable step size, the simulation duration will be less. Okay, it can vary according to our model. So if we want to do codegen, or for if we're using for model based development, we should be using the fixed step solver, or we can't use variable step solver here. So you can see here, we first we'll see, are we using fixed step solver? If yes, then we see do we have any continuous states. If we are having continuous states, then we will be using fixed step continuous solver. Otherwise we will be using fixed step discrete solver. And if we are not using fixed step solver, then we will see if are we having any continuous states in our model. If yes, then we will be using variable step continuous solver, and otherwise we will take variable step discrete solver. So these are the examples of variable step continuous solver and variable step continuous fixed steps continuous solver, OD1, OD2, OD3, OD4. You can see here how these are classified: fixed step, variable step, the fixed step discrete, variable step discrete. For the continuous states, ordinary differential equation, differential algebraic equations. If we are having a fixed step ordinary differential equation, then OD3. If we are having a fixed step and a differential algebraic equation, then 14x. For variable step, there also we are classified into step or non-step. So according to our model we can use the solvers. We see one example here. Wait. So this is example from my previous video. So I'm just showing this example to show how what are the sample time is taking according like states of the model. Okay, So you can see here the states. So all black colored blocks are the continuous ones, and red color, this scope delay, is discrete, that are running at 0.01 period for. And yellow colored is hybrid. So my input is coming as a continuous, but output is coming as I need to give as a discrete. So because of that, it's hybrid, taking the both properties. And all pink colored are my constant blocks. Okay, now we'll use one example. So here I'm giving the sample time. Two inputs I'm using. One input is having the sample time of 0.75. Other input is having a sample time of 0.5. Then I'm adding the both values and giving to one display block. Okay, and you can see here also sample time. Oh, green color is having the discrete value 2, having sample 0.75, 1 having sample 0.5. Okay, and one more thing, how we can select the solver first. Go to settings, solver settings, and then go here solver. You will see the option variable step, fixed step. For now I am selecting the variable step, and there is also options automatics, automatic, auto value it will take, discrete, all the OD values whatever we saw earlier, OD 45, 23, 113, non stiff, OD 15s, stiff OD 23s, modified stiff, and OD 23 TB. So all with these selections we can do. Okay, and step size also we can give, how much step size we want to give, that we mentioned earlier. So now I am selecting here as a fixed step, discrete, I don't want any continuous here, and my step size is I can give 1 or anything. For now I'm giving 0.5. So let's see what error is coming here. Okay, so you can see here the sample time period 0.75 of solver constant is an integer multiple and fixed step of 0.5. We can't give the only one sample time, we can't, because it will be going to miss one sample time here. Okay, so we will be changing now that we will take one integer multiple of both sample times, 0.25. So you can see the colors are also changing because of different sample times. And I'm going to my workspace. So you can see here this is a timeout of my different samples, 0.5, 0.25, 0.5, 0.75, 1, 0.25, 0.15. At 7th of sample it's giving me. Okay, and now we'll change to the uh, variable step size. I'm giving discrete and no continuous. Step size I'm giving automatically, or auto I'm giving. Okay, and you can see here is taking the automatically sample time with the sample size of 0.2. Here it's automatically taking the sample size of 0.2. Earlier we manually assigned the sample size of 0.25. So if here the sample size is 0.2, so that's why it is taking the more time as compared to the fixed step, otherwise it usually takes less time. So it's 0.4, 0.5, 7, 7.5. No, not the sample size of 2.5, it is varying actually. Here you can see 0.5k and then 0.7 only, and now it's 7.5. Only the difference you can see, 7 after 7 it's coming as 0.75. So our other input is having the sample time of 0.75, because of that it's changed, then it's taking 0.951. Accordingly the sample size is varying. Okay, so that's all about the solvers. If I will be linking some papers from the Mathworks, you can go through that, and if you can want to do more research or want to read more about that solvers, then you can go through that links. Okay, thank you, bye bye.